My name is Sydney Schaefer, and I am 16 years old, and I'm going to play Clair de Lune by Debussy.
This explanation is the Newton's law explanation for gyroscopic action. It is based on Newton's first law of motion. The first law of motion says that a body in motion will tend to stay in linear motion unless acted upon by an unbalanced force, or a body at rest will stay at rest unless acted upon by an unbalanced force. If we take a spinning wheel and suspend it from just one side, the wheel will fall over and be vertical. On the other hand, if we actually spin the wheel and suspend it from one side, it doesn't behave that way. And why is that the case? Well, if we look at this red particle and the blue marked particle on the wheel, you will notice that if I suspend it from the back, then the red particle moves towards you and the blue particle moves towards me due to the force of gravity that generates a torque that tends to spin the wheel in that direction. After 180 degrees, this red particle, which was moving towards you, now, due to the torque caused by gravity, wants to come towards me. Those two motions then cancel one another. And the result is that the wheel doesn't fall over if it's spinning. Likewise, the blue particle that initially was moving towards me, after spinning 180 degrees, now wants to still move towards me, but the torque caused by gravity wants to push it towards you, and those two motions again cancel, and so once again, the wheel, the spinning wheel, does not fall over, even though it's supported by one side. Let's see what happens after 90 degrees. So initially, the torque due to the force of gravity wants to push the red voxel towards you and the blue voxel towards me. After 90 degrees, the red voxel still wants to move towards you due to Newton's first law. The blue particle wants to move towards me due to Newton's first law, and those two motions lead to a twisting motion of the wheel. That motion is known as gyroscopic precession. So if the wheel is spinning in this direction, we would predict that the wheel should precess in that direction. On the other hand, if the wheel was spinning the other way, in this direction, we would predict that the wheel should precess in the opposite direction. So let's see if that's in fact what happens. So I'm going to spin this wheel in this direction initially, and after it spins, we should watch it precess in this direction if I support the axle by this string. So here we go. Sure enough, it precesses in the direction that is predicted by the Newton's law of explanation. On the other hand, if I spin the wheel in the opposite direction, then we would predict that it should precess in the opposite direction also. So, sure enough, precesses in the direction that we expect from Newton's law. That ends part one of Newton's law explanation. That part is based on Newton's first law.